Hello, everyone from 3 a.m. in Taiwan. I'm excited to have Nolan and Jim with me to talk about some exciting things that we've been working on at Open Library. So last time I was giving a talk, Trevor let me know a third of the way through that we had server outages, and so that was a blast. And so I'm hoping this time it goes a little more smoothly. So I'm going to share my screen really quickly. And all right, looks like we're all set. So hello, my name is Mech. I help run the Open Library over at the Internet Archive. And today I would like to tell you about reading between the lines. This is a talk on how community and technology are helping the Internet Archive capture the essence of a book's genome. So I have a few goals today with this talk. The first is just to teach people at the Internet Archive about some of the neat technology and tools that we have available to us. One of these is the Google Colab Notebook. Another is I want to talk about how we're helping give patrons a voice so that they can say what they want to say on the Open Library. I'm hoping that we can save people time who want to make edits to the Open Library by automating easy tasks so people can focus their time on the harder things that really require human expertise. I'm hoping that we can fuel an open ecosystem by creating more public data. Right now, there are a lot of books that are kind of shielded behind a lending system. And if there's a way for us to get insights from those books out to more people, then there's amazing things we can do. Which leads me to my next point, which is I'm hopefully going to show you how we can make our tools more useful in a world where we do have a rich ecosystem of public data. And finally, this talk is really about celebrating a few people's work. Jim has been doing a absolutely stellar job. He was previously a volunteer and has been working with us on a feature called Book Notes, which we get to reveal today. And Nolan also first visited us as a high school student at Internet Archive headquarters, and he kept in touch and has now been one of the primary leads on the Open Book Genome Project. So if you happen to like this talk, there is a prequel at Aaron Swartz Day. We gave a talk on building a library in the matrix, and this is kind of going to take off where we left off there. And so that talk started off by proposing a problem that we had spent around 250 years as a country in the United States trying to solve a singular problem, which is if a book is not in one location, or if a book is in one location, it's not in another location. And uh, as we have been going digital, we solve this problem at the Internet Archive through a series of practices such as building a catalog system of books to help us identify significant works that we might want to acquire, by employing practices like controlled digital lending, which allow our books to be available digitally and then allows people to borrow them and access them, by partnering with open libraries across the country to help increase the number of books that are available in the ecosystem, and finally by showcasing these books on platforms like Open Library so that they are discoverable. And we're during the non-pandemic times, we're doing around 50,000 of these books a month, the digitization and making available. So this kind of brings us to the upper mantle, the outer layer of the crust of what's possible with books. So we have around 5 million books that you can read or borrow directly on the Internet Archive. And thanks to the work of Drini and others, we now have a library explorer, which gives you control over browsing through the stacks of 22 million works. And you can also do things like browse by author and subject. And the work of folks like Geo and Zim and Merline have resulted in improved OCR, the way that we take the images of the books and turn them into text. It's resulted in full text search and other offerings like our copy and select text within a book. And this has allowed us to do some really powerful things beyond just the surface level make a book available digitally. For instance, here is a search that we're seeing for the text HTTP within our books. And we see there's almost 1 million books on the Internet Archive that contain links. And we've been able to leverage that information of searching across books to identify links within books and then augment our book reader so that they're actually clickable. So this is a a live demo. I'll cross my fingers here. And I'm going to zoom in because it's just a little bit hard to see. But you can see because actually Giacomo and Drini had previously implemented this text selection feature, we now have the capability of identifying words or phrases within our books. And here, if I click on this link, right from the book, it'll bring us to the referenced URL. So where do we go from here? What's below this kind of surveying manifold? I think there's a quote by Carl Sagan that captures it really well, which is, if I finish a book a week, I will read a few thousand books in my lifetime, about 0.1% of the contents of the greatest libraries of our time. The trick is to know which books to read. And even the giants have had trouble trying to figure out this problem. Like, I don't know how many of you have read 30,000 books on calculus, but Amazon doesn't really offer a great way of filtering through all of these results other than star ratings and reviews and fancy recommendation systems, which are not very transparent. There are some companies that have really had interesting approaches to this problem. One of my favorite was in the year 2000, Pandora created this thing called the Music Genome Project. And the Music Genome Project was an effort to capture the essence of music. They hired a bunch of experts who helped evaluate every song on more than 450 attributes, like the level of vibrato, whether it's more jazz or maybe classical, all sorts of different aspects. And in the year 2003, there was another project coming out of, I believe, the University of Ohio called the Book Genome Project, where they followed suit and they started using over 32,000 genomic book measurements to identify things like measuring the tone of the book, the pace, and all of these other criteria around characters, story, and language. To give you an idea of the scale and the complexity of this system, they had over 2,000 ingredients just to describe the story's DNA or the theme. And I love this sentence. Their ultimate goal was trying to differentiate one book from another in a crowded and complex bookosphere. So what did this actually give us? It gave us some incredible visualizations. The first two graphics here are a breakdown of the actual plot, the progression of a book. And here we're seeing these spikes when there are areas of a book that were high energy or exciting, or even dense with stories about supernatural and vampires. And so you can actually compare the sequence or the progression of a book's plot between one Stephen King novel and another. And at the bottom here, we're almost seeing what looks like a day-by-day GitHub contributors chart. Has a contributor made any commits on this day or this day? Except here, what we're seeing is a batch of pages in a book and whether those pages signaled sexually explicit or adult content. So here on the left, we see what might be an adult book that is red, signifying that it might have a lot of inappropriate scenes, whereas this is contrasted with 50 Shades of Grey. And I believe they were actually using this to make age-appropriate recommendations. So pretty powerful things that they were able to accomplish with this Book Genome Project. And they also created a website, kind of like Open Library, where you could visualize the different breakdown of a book in terms of how romantic was it versus how much did it embody pain and fear and negativity versus vampires or other elements. And it was beautiful. The whole project was wonderful. And then, as happens with many things we're too familiar with at the Internet Archive, in 2014, Booklamp and the Book Genome Project were acquired by Apple and it shut down. Fortunately, we had a new hope. Very recently, Nadia, from one of the founders of the Storygraph, took a different approach, a human-first approach to empowering patrons to crowdsource all of these different subjective aspects of a book. And the result is absolutely terrific. we are starting to see new insights that are not easily achievable just by a computer going through and determining, is this about vampires or is this about, a historical figure? Now we're getting things like, does the community believe that this book has a diverse cast of characters? Are the characters lovable? Is there strong character development? And so leveraging the power of community both gives them a voice, but also enables us to reach consensus on metadata that might not just be as clear cut as fact. So I love the book title by Yogi Berra of "When you come to a fork in the road, take it." And so rather than just choosing a technology-driven approach or just choosing a community approach, we've decided to have a heterogeneous approach where we try both to structure data and extract insights and also leverage the community. And so I would love to hand it off to Jim Champ, who has been the mastermind behind our book notes project, to talk about how we've been building these human first mechanisms to crowdsource truth within Open Library.
Hi, I'm Jim. Let's see, I guess we can go straight into a demo of the book notes, which should handle seeks to handle the human aspect of what Mech was talking about. Let me go ahead and share my screen. Okay. So say I'm browsing Open Library and I want to find some information about a book, say The Ultimate Hitchhiker's Guide. I see that there's like a lot of subjects, many editions, the publishers of these editions, even like the prices and where I can purchase the books. But nothing about how maybe the book makes me feel or what people think the appropriate audiences, like age levels and this type of thing. So I've been working on this feature called My Book Notes. So when you click the My Book Notes link, you get this modal. You can leave personal notes about the book that nobody else can see but you. It's been about maybe 2 decades since I've read this book, so maybe it's worth a reread, worth reading again. I can save that note and look at it later. See, I remember that this book was pretty entertaining. Pretty original. It's kind of a sci-fi humor book. Fiction. And I don't have to fill out every one of these. Once I'm done, I can click outside the modal and all my observations are saved. Since I was the only person that left observations for this book, we can look at something that a couple other people have left observations for. Here above the editions table, you'll see a link called Reader Observations. If we click on this, it'll bring up a component that tells how many patrons have left observations and a percentage breakdown of what they thought. You can also adjust your observations from this page as well, or from this link as well. And then if you want to see all of your observations, you can navigate to the My Book Notes page. Here you can see books or notes and observations for all of the books that you've left observations for. You can update your observations, update your notes or delete notes. And I think that's about it. That's about it for me.
Awesome. Thank you so much, Jim. I'm going to share my screen again. So one of the reasons why this is so useful is right now, Open Library is it's more or less a collection of facts. And so what we would like to do is give people a subjective way to express their thoughts about a book. Otherwise, at the bottom here, you can see a patron on Open Library who keeps removing the label not science, or keeps removing the label science fiction because they're upset that there's a right or wrong answer, that someone in the community might think that a book is science fiction and that is an authoritative statement that it is. And so this kind of gives people a way to express their thoughts in a more nuanced way. Another problem with classical reviews is that oftentimes people will make reviews around the quality of their shipping experience rather than the book itself. And so, as Cory Doctorow explains, there's this a meta crap problem. All right. So here are some of the screens from the book notes. And then some other things that Jim Shelton helped us with are how we could actually incorporate all of this new rich data into our experience. And so here's an example of how we might actually be able to search in the future for books that have slow pacing or fast pacing or an ominous mood based on the consensus that has been kind of trickulated or percolated to the top by our community. You could also imagine a new page, kind of like our subjects page, that allows you to browse books based on these different types of observation types. What are the most useful books according to the community? And you could see a author's breakdown of maybe an author is predominantly fast paced. And so you can find authors based on this information. And finally, here's kind of a radar graph of exploring moods from your own library and understanding whether you are a level, maybe a level 5 vampire reader, or whether you typically read suspenseful stuff or happy material, etc. So the other approach that we've been taking is with an open version of the Book Genome Project, trying to create something that leverages technology to read books for us and to derive insights in a technological way. And I would love to hand over to Nolan to talk about his work on the Open Book Genome Project.
Hello there, my name is Nolan. I'll share my screen as well. Okay, great. Here we are. So the Open Book Genome Project, a literary fingerprint for every book. So that's by me, Meg, Ishan, and others who are contributors in the whole community. So what is the Open Book Genome Project and why do we need it? Today, when the Internet Archive digitizes a book, it goes through the drive process, which only we control. So that's for driving other types of files based off of the scanned images. So imagine if there's an open source pipeline where members of the community could contribute their own modules and solve their own problems to create their own pipeline for solving those problems. And then as a result of that, driving deeper public insights for books. As an example, Lisa, our librarian, might be working on the Universal School Library, and she wants reading levels for the collection. And I'm also from the community, could contribute a reading level Open Book Genome Project module that's able to analyze the text and then estimate what the reading level is for all of the books in the collection. So this module, along with modules from others in the community, would get run on Internet Archive books every quarter, producing public insights that can be used by anyone. And these insights could then be integrated back into Internet Archive services like Open Library and help the community solve more problems. So for example, you could make those reading level data searchable, or other n-gram data, whatever analysis somebody would want to put into a module could be added into the product itself. So another example of a problem is adding books into the library. Right now, there are about 210,000 books that the Internet Archive has digitized, which we're not currently lending because it's missing key metadata, mainly like the ISBN, to be able to match it to like publish date and other stuff like that. So there are two parts to this problem. There's an easy part, which is there are about 68,000 items that have identifiers in the title or other pieces of metadata that are machine readable and can be pretty easily matched with open library records. And if there's a match, then that item can then be made available to patrons for borrowing. And there's 41,000 of those books, which we may be able to make easily lendable right now, which is great news. But there's another part of the problem, the hard part, where there are 140,000 that have no identifiers easily available, that are not in metadata, it's not in the title. And you might think it's a lost cause, but the opportunity is that there's possible identifiers like ISBN on the copyright pages of these books. So that's where the Open Book Genome Project swoops in to save the day. Obligatory XKCD. Here's an example with the book Open Access. Let's say that the archive does not have the ISBN or other identifier information available for this book, so it's not currently lendable. So this book would be sequenced. The copyright page detector module would find attributes such as maybe the copyright symbol on the page, which would then indicate that this is the copyright page. Then an ISBN extractor module would find the ISBN in the page, verify that it's a valid ISBN, and then output it in the genome of the book itself, as you can see back here in this notebook. I can actually give a quick demo of this. So here's the Open Book Genome Project sandbox, which is just a Google Colab. So just a Jupyter notebook that anybody can use to run their own sequencers and kind of play around to see how this whole environment works.
Something really magical about the Google Colab tool that we're seeing right here is, Nolan, if you don't mind scrolling to the top really quickly, this is a step-by-step guide which even installs the Book Genome Project libraries directly in your browser in Google's cloud infrastructure. So you can see under the installing to the cloud step, the library has already been installed in Nolan's browser, and so he can now use it step by step in a tutorial without having to fuss around with being, a programming expert or having to get this set up on his computer.
That's right. And there's a guide kind of describing all the different steps that we're using here. So going back to this example with that open access book, which the identifier is right here, I can just run this little block of code by pressing the play button. Simple as that. And almost immediately it'll download that book, and then it will output in a machine readable format, the ISBN, which we can then do whatever we want with, which is awesome. Another example quickly is for the book Goody Two Shoes, another book that is publicly accessible. I can run this one, and it'll print out the most common two-word phrases, like all this stuff, Miss Marjorie, Marjorie Two Shoes, 21 times, 20 times, little Marjorie. So then you can start to do some natural language processing stuff and get some insights into what the book is about, as well as some reading level estimations going on here. And we can plug in any library we want to get the reading level information just based off of how complex the text is. So going back here. There's also Library of Congress catalog numbers, which are another opportunity for identifying books as well. So now that we're able to make that hard problem into an easy problem because the ISBNs are now machine readable, we can add that into the metadata for the item and make it accessible to patrons. We've already run this, the first iteration, and have been able to identify 12,000 more books that we will now be able to add to Open Library that previously was not lendable because there's no ISBN or other identifier information, which is now there. And with future iterations, with adding in new identifier identification, this will get even better. So this is a big deal. So what other insights can we glean from the Open Book Genome Project? What can we use this for? So one thing is identifying important terms like people, places, topics, and dates. Calculating reading level and pace, like I showed you, maybe even generating book summaries using tools like GPT-3. extracting citations, references, URLs, and identifiers, kind of like the demo that Mech showed you, and comparing book similarity based on themes. But the real magic happens when developers have open access to these genomes, can add in their own modules, and then can use it for their own tools. And I believe Mech or Drini will be giving a demo of that.
Awesome, thank you, Nolan.
Thank you all.
Sure. Why don't I share the demo here, but not without first saying that Drini also contributed a ton to driving this feature. So if you've ever been on Wikipedia, then you've probably seen that when you hover over a word, you get this smart pop-up that gives you context without having to leave the Wikipedia page. And so we have been able to develop a proof of concept, which kind of hard codes a genome behind the scenes, and then allows us to click entities throughout the entire book here. So whenever an entity like Socrates appears, we can click it, and just in time, it will load all of Socrates' information from Wikidata and Wikipedia, and then also match it to any books that are in Open Library. And this is a live thing that's working. So if we click the Apology of Socrates, this will pull up the actual book. And now instead of seeing the Socrates as an author, these are the actual editions of this work. And so you could flip to any arbitrary page. And what's another good one? Callicles, I guess, is a good one. We can click on that, and that will pull up the Wikipedia information. So this is very much a proof of concept. Right now, we have not finalized any book genome aspect of pulling out all of the natural language entities. So some of this is hard-coded as a proof of concept, but the book reader is able to present things in this way because of the work that Giacomo and Drini did with text selection, which is how we can actually map all of the text and select these regions. So coming soon, I wanted to also celebrate the work of Brian Newbold and Martin and Mark Graham and others who have been working with organizations like Wikipedia and Wikidata, and also the Book Syllabus Project, which has resulted in a richer ecosystem of us being able to identify the latent relationship and the graphs between books. And I think that's really the next frontier after the mining section that I just talked about. And one other project that I'm really excited about is the Best Book On, which is another community project within the Internet Archive's Open Library community. And the Best Book On is leveraging all of the work that I just showed you to help people make recommendations by comparing books against each other. So maybe I would say that I thought that the Hobbit was better than the Return of the King, and then I would provide examples as to why I thought one book was maybe better for me than another, and that emerges as a graph where we can make deeper insights. And then finally, as we move into the future, perhaps there's an opportunity to talk to books by using tools like GPT-3, or instead of just recommending a book, recommending a directed sequence of learning material, really dropping someone into a knowledge graph and helping them discover the next book that's customized and tailored to their specific learning style. And that's what we've been working on, hopefully an exciting look into the future. And thanks so much for spending time with me, Nolan, and Jim today. And thank you, Nolan and Jim, for all of your amazing hard work in making this possible.